Right, we're going to start with lesson 9C in S2 computer number systems, and we're mainly focusing on operations. This lesson is only compulsory and for examinational purposes up to page 15. So I'm going to highlight that because beyond page 15, you guys don't need to study or know for exam purposes. So firstly, we're going to look at the binary number system and operations. So today, remember, we're focusing on operations mainly. So binary number operations. Before we learn how to add and subtract in binary, we have to practice counting. So just like in grade R and grade 1, you had to first learn how to count before you could do operations. So the same will now apply to the binary system and doing operations with binary numbers. Here are the decimal numbers from 1 to 10, and I'm not going to waste any time discussing them. You guys are all familiar with that. And then we have the binary system. Now, this is where we're going to do something different. I'm going to show you how I got myself a shortcut in remembering it. So right, so you don't have your 0 there, but then it's 1, 10, 11. Then you start again with 100, 101, 110, 111. Then you go for 1,000, 1,001, 1,010, 1,011. So if we look at the pattern, this is what you will notice. 1, 10, 11. Then 100, 101, 110, 111. Then you have 1,000, 1,000, oops. 1,001, 1,010, 1,011. Right, and so it goes on. So this is the pattern, and the binary number is 1, the decimal value is 1. The binary number is 10, the decimal value is 2. How did we get from 10 to 2? Well, this is what you do. You write it in the binomial manner, in binomial numbers. So you have 2 digits, 1 and a 0. Then you write 2 to the power of 0 and 2 to the power of 1. So 1 times 2 to the power of 1 plus 0 times 2 to the power of 0. So this over here is what we did in the previous lesson. So I'm not going to talk too much about that because you are already familiar with that. Right, key results. Now this is what we're going to NB. This is like one of the core cardinal facts that you have to know, and you have to memorize it and make it your own. So we're going to NB and NB and NB as much as you like. The decimal we're not going to bother with. You know it. So I'm not going to bother with this. This is common sense. What we're going to focus on will be the binary system. So decimal is your favorite, it's your friend. You know it by heart. Binary is the new guy, right? Or new girl. So 0 plus 0 is 0. 1 plus 0 is 1. Now this is where the snag comes in. 1 plus 1 equals 10. So you have to memorize that. 1 plus 1 equals 11. Now how did we get to 10? Let me just show you here again. Remember 1 plus 1 equals 2, but the binary value for 2 is 10. So that's why when you add 1 plus 1, it's not 2, it is 10 because we're working in binary. 1 plus 1 plus 1 is not 3. In decimal it's 3, but in binary it's 11. Right, so let's quickly look at addition with binary numbers. We use the same principles as when adding decimal numbers. So straightforward, it's something you know. Align the numbers below one another and start adding from, very importantly, right to left. So we're starting from the right-hand side and then moving to the left. Remember the key results. Example 1, add the binary numbers. Firstly, align the numbers below one another. It's important. Write zeros as place numbers in positions where there are no numbers. So, for example, here, it's 110 plus 1. So 110, and instead of just writing a 1, you put place values. Sorry, placeholders. So write zeros as placeholders in positions where there are no numbers. So I want you to do that. And then add 0. Right, this is now where we're going to start. We're going to first start off with the binary numbers. These are binary numbers. So we will give you binary numbers to add in the exam or test. Then you write binary. You write them underneath one another. You put placeholders where there are numbers missing. And then you just start. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 0 is 1. Now remember, this is now a binary answer. Binary operation, so the answer must be in binary. And where did I get that? This key results I used when I added over here. So now I'm going to convert from binary to decimal. How do I do that? That's what we did in our previous lesson. Almost said last week, but what we did in our previous lesson. So you have 3 digits. So 2 to the power of 2, 2 to the power of 1, 2 to the power of 0. 1 times 2 to the power of 2 plus. So this 1 is that one. This one is that one. And that one is this one. So if 1 times 2 to the power of 2 gives you 4. 1 times 2 to the power of 1 gives you 2. And 1 times 2 to the power of 0 gives you 1. So 4 plus 2 plus 1 gives you 7. And then base 10. So remember, base 10 just tells us that we have a decimal number. And then just check. That equals 6. That equals 1. 6 plus 1 gives you 7. Example 2. This we're going to add. Align the numbers below one another, as you see over here. Add the ones below one another in column on the right-hand side. The answer is, okay, so before we do that, this is very important. 1 plus 1 gives you 10. So remember, 1 plus 1 gives you 10. So you write the 0 and the 1 of the 10. 1 plus 1 gives you 10, plus 0 gives you 10. So you write it out like that. So I'm going to do it for you. So they give you a binary number. You write binary as you see over here. One plus 1 gives you 10. So we know that 1 plus 1 gives us 10. But we only write the 0 and you carry the 1 over. 1 plus 1 gives you 10, plus 0 gives you 10. Right. Now remember, this is now a binary number. So write base 2. Now we convert from binary to decimal, then we get 4. This is the work we did last week. Binary to decimal, as you can see over here. Binary 11 gives you 3 in decimal. Binary 1 gives you 1 in decimal. 3 plus 1 gives you 4. Example 3. We start with binary 11 plus binary 11. I'm going to write it out, and as I do it, you will see. One plus 1 gives me 10, so I write the 1 down. 1 plus 1 gives me 10 plus 1 gives me 11. You see? So now you write the binomial number, and we're going to convert it to decimal. Then 1 times 2 to the power of 2 gives you 4. 1 times 2 to the power of 1 gives you 2. 0 times 2 to the power of 0 gives you 0. 4 plus 2 gives you 6. So the answer is 6 in decimal. So in binomial it's 110, and in decimal it's 6. Right. Add binary numbers. 0 plus 1 gives you 1. So you write the 1 down. 1 plus 1 gives you 10. So you write the 0 down, and the 1 you carry over. 1 plus 1 plus that 1 gives you 11. And you carry the 1 over. 1 plus 1 gives you 10. Write the 0 down, you carry the 1 over. 1 plus 0 gives you 1. And you write it down. Right, now you have the binomial. Now you convert it to decimal and you get 21. As many zeros as needed may be written to the left of the binary number as placeholders. So let's just also write that down. So always do the decimal check. You have your binomial operation, you have your conversion, and always do a decimal check. So 1, 2, 3 things you need to do. You have your binomial operation, you do your conversion from binomial to decimal, and you do your decimal check. All right, add the following. I'm going to just add it. Then you can see how I do it. You see how important it is to write everything neatly underneath it. So otherwise you can make mistakes easily. So at the top we can write the 0. That's why you see the 0 there. Plus 1 plus 1 gives you 10. You write the 0, carry the 1 over. 1 plus 1 gives you 10. 1 plus 1 plus 1 gives you 11. 1 plus 1 gives you 10. 1 plus 1 gives you 10. You see, answer is the same. Then you're going to take the binomial and convert it. Then you get 36. Do your decimal check, 15 plus 21. So this is 15, that one is 21, give you 36. Right. So do your binomial operation, your conversion, and your decimal check. Exercise 1, you're going to get 5 minutes to do number 1 to 3. If you need 10 minutes, it's also fine because it's in the beginning stages. But yeah, try to do it within 5 minutes. So press pause now, work it out, and then you press play again. Right. The first one, 1 plus 0 gives you 1. 1 plus 1 gives you 10, so you write the 0 and you carry over the 1. 1 plus 1 gives you 10, you write it out. Then the second one, 0 plus 1 gives you 1. 0 plus 0 gives you 0. 1 plus 0 gives you 1. 1 plus 1 gives you 10. You write the 0, you carry over the 1. 1 plus 1 gives you 10. You write it out. Then you add the 3 values there. 0 plus 0 plus 1 gives you 1. 0 plus 1 plus 0 gives you 1. 1 plus 1 gives you 10. You write the 10 out. Now we're going to look at subtraction with binary numbers. Align the numbers as you would do in ordinary subtraction problem. Write the larger number above the smaller number. That's common sense. If the smaller number has fewer digits, line them up from the right as you would in the decimal base 10 subtraction problem. Use zeros as placeholders. So this is important. Some binary subtraction problems will be solved easily, just like with base 10 subtraction. 1 minus 0 is 1, 11 minus 10 is 1. There is, however, one special rule necessary to complete any binary subtraction problem. This is the rule that teaches us how to borrow from the digit to the left in order to solve a 0 minus 1 column. Right? So what's important is that you need to know that in order to say 0 minus 1, you're going to borrow from the one on the left. So this is the borrow rule that I'm going to discuss now. Starting from the column on the right, I'm going to now first show you my explanation and thereafter I will read theirs. Okay. And then you pick whatever makes sense to you. Zero minus one. We can't say 0 minus 1, so we go and borrow. Then you would have a 10, but remember, 10 in binary equals a 2 in decimal. So we're going to NB that. 10 in binary, because we're working in binary, equals a 2. So in actual fact, you're going to do this. Take a color, pencil something, and write this for yourself. 2 minus 1 is 1. 0 minus 0 is 0. 1 minus 0 is 1. And now you will see this is the answer. So where you would borrow and you have 0 there, then you have a 10 here, remember? So instead of then writing that 10, you write in color for yourself 2 minus 1 is 1. 0 minus 0 is 0. 1 minus 0 is 1. You can read through this, but I find that sometimes the explanation here can make you feel confused. So we're not going to do that. To understand how we reach the answer, this is more important to me. How we reached this answer, we should convert it back to decimal. So binary 10, if you convert it to decimal, 1 times 2 to the power of 1 plus 0 times 2 to the power of 0 give you 2. So there you can see binary 10 equals decimal 2. Binary 1 equals decimal 1. Therefore, 2 minus 1 is 1. So the answer to 2 binary minus 1 binary gives you 1 binary. So the binary number 10 is actually in decimal form a 2. And this is going to be extremely important for the subtraction. So I'm going to NB it. Right, and this I'm just quickly going to read. If you already understand it the way I showed you now, then do not read this. If you don't understand it, maybe you should pay attention to the explanation here. Another way to look at this is to realize that if an 8 is borrowed when working in binary, the borrowed 8 will become 2 4s in the column to the right. Therefore, in binary, 10 is written down. Remember that 10 in binary is actually a 2 in decimal. Or if the 4's column has 2 borrow from 8's column, then the 4's column receives 2 4's. So it all depends whether you understand that. I'm just going to show you the way I understand it, and then you can make a decision. Remember now, this is binary, so we just add the 2 zeros for placeholders. 0 minus 1, you can't say. So then you go borrow. Then there's 0 left. Then you have 2. Then you have 10, remember. But we know that a 10 is actually a 2 in decimal. So 2 minus 1 is 1. 0 minus 1, you can't say 0 minus 1. We go borrow. Then it becomes a 2. 2 minus 1 is 1. 0 minus 0 is 0. 1 minus 0 is 1. And there you have your answer. Each time we borrow 1, we cross out the 1 and write a 10 on top of the 0. So remember the 10 then in the end is a 2, the one that I wrote in blue. Example 7. I'm going to work it out quickly. You can't say 0 minus 1, so now we go borrow. Remember it's a 2 because it's a 10. So then I borrow 1 to carry over. 1 equals the 2. So then we say 2 minus 1 gives you 1. 1 minus 0 gives you 1. 0 minus 0 gives you 0. So therefore, there's your answer. I'm going to just read what they mention here. You will see that's the answer. We cannot borrow from the 0 in the second column. That one there. From the right, therefore, we have to borrow from the third column there on the right-hand side. In decimal, 1 4 equals 2 2's. So that's why you have 2 2's over here. So then you borrow 1, then you give it to him, then it's 2 2, so 2 minus 1 gives you 1. 1 minus 0 is 1. 0 minus 0 is 0. So borrow 1 2 to use in the other place, write it as a 10 in binary on top of the rightmost 0. Now then we have the borrow rule, which we call the visual method. The borrow procedure is sometimes done with a different method of writing. It indicates visually for you to see easier what we're doing. That if, for example, an 8 is borrowed, it becomes 2 to the power of 2's or 2 4's. As you can see over here, the 2 1's indicate 8 that becomes 4's, 2 4's. So the 8 becomes 2 4's. If one of the 4's is borrowed by the 2's column, 1 1 is crossed out and 2 1's are left above the 0 in the 2's column, as you can see over here. The 2 1's show that one of the 4's become 2 2's. If one of the 2's is borrowed by the units column, it is again indicated that the 2 that were borrowed will become 2 1's by writing 2 1's above the 0 on the right hand side, as you can see over there. Right, so I'm going to do example 8, And as I do it, I'm going to explain it to you. Right, so you borrow here. So remember you have now 2. 2 minus 1 gives you 1. 1 minus 1 gives you 0. 1 minus 1 gives you 0. 1 minus 0 gives you 1. And there's your answer. So in binary, this is 16. That equals 7. So 16 minus 7 equals 9. That equals 9. So you test your answer also like that. Test it by converting it to decimal. So you may choose to do the borrow procedure with this method. We will name it the visual method. Then example 9. Subtract the binaries. I'm going to do it quickly. Remember, this is a 2. 2 minus 1 is a 1. 1 minus 1 is a 0. 1 minus 0 is a 1. 0 minus 0 is 0. 1 minus 0 is a 1. There you have it in binary. Convert it from binary to decimal. Then you get 21. Convert this to decimal, you get 24. Convert this to decimal and you get 3. 24 minus 3 gives you 21, and you can test it to see whether you worked accurately. Then they have the visual method, which I just showed you now. So if you understand the visual method better, then you use that. If you understand the original where 10 equals 2, but remember in the beginning you had 10 there, so you borrowed 1, in other words you have 1 left. So if I were you, I would go for the visual method. But you can pick and choose the one you like. Right, the only difference in these two methods is we only write ones in place of 10 when we borrow. So instead of writing a 10, we write a 1. There you can see instead of writing 1, we wrote a 10. So the difference is there we wrote 10, here we wrote 1. So you pick the one that you feel most comfortable with. Now you're going to do exercise 2. You can give yourself 10 minutes to do it. So press pause on your screen, work it out, and then you press play again. So press pause now. Okay, 1 minus 0 equals 1. 0 minus 0 equals 0. 1 minus 1 equals 0. 1 minus 0 equals 1. Then we do the second one. This one I'm going to write out. We have to go borrow. 2 minus 1 gives you 1. 0 minus 1, go borrow. 2 minus 1 gives you 1. 0 minus 0 gives you 0. 1 minus 0 gives you 1. 1 minus 0 gives you 1. There you have your answer. Always double check whether you need to convert it to decimal or whether you can just do the operations in binary and leave it in that format. Then number 3. One minus 1 is 0. 1 minus 1 is 0. 2 minus 1 is 1. 0 minus 0 is 0. 1 minus 0 is 1. Then we do number 4. One minus 0 is 1. 2 minus 1 is 1. 0 minus 0 is 0. 2 minus 1 is 1. 0 minus 0 is 0. 1 minus 0 is 1. Then we look at number 5. So 2 minus 1 is 1. 1 minus 1 is 0. 1 minus 1 is 0. 1 minus 0 is 1. There you have your answer. Multiplication with binary numbers. Well, I have good news for you. Multiplication with binary numbers is done exactly the same as in decimal system. There is one shortcut. Any binary number multiplied by 2 can be written as the number itself with only an extra 0 at the end. For example, a 101 binary times 2 decimal. Please note that it's decimal. Then you just add a 0 to the binary number. If a binary number is multiplied by 2, just add a 0 to the number. So that's if you have a binary number and you might multiply it with a 2 decimal. Right, in example 10, multiply binary numbers. These two numbers. Right, you guys, you do a normal multiplication sum. So up till here, it's basics as you know it. The only thing that you need to focus on for me is this part over here. 0 plus 0 is a 0. 1 plus 0 is 1. 0 plus 1 is 1. 1 plus 0 is 1. And 1 plus 0 is 1. Right. You can quickly look at example number 11. I just quickly need to find just something here. So just for 1 minute, you will hear silence, then I will speak again. 1 minute silence, so you can so long look at example 11. Right, and I'm back. Right, you multiply up till here, straightforward. Over here, you're going to just add 0 plus 0 plus 0 gives you 0. 1 plus 0 plus 0 gives you 1. 1 plus 0 plus 0 gives you 1. 0 plus 0 plus 1 gives you 1. 1 plus 1 gives you tens, 0, and you carry over a 1. 1 plus 0 gives you 1. And then you have 1 plus 0 give you 1. Now you have your binomial answer. Then you convert to decimal. Then you get 110 decimal. Remember to write the 10 there to show it's a decimal number. Then division with binary numbers. Right, division with binary numbers works the same as division with decimal numbers. So divide the binary 100 divided by 10. So it's just like normal division. Up till here, straightforward. 100 divided by 10 give you 10. Subtract and you have 0, 0 left. Divide the binary number 1111 divided by 101. So it's only where you have the subtraction where you have to remember that you're subtracting in binomial with binary numbers. So 111 divided by 101 gives you 1. Then you subtract 111. You subtract 101 from 111. Right? Then you have 10 left. Bring down the 1. So 101 goes in 101 and once. 101 minus 101 gives you 0. So just read here, 101 can only divide into 111 once, therefore write 1. Multiply 1 with 101 and subtract. The answer is 10. The answer 10, bring down the rightmost one. This one you bring down. 101 divided by 101 equals 1. Write down 1. Multiply 101 with 1 and subtract. Then divide the binary numbers. Right, just for your information, 11,011 equal in binary 11,011. This is binary. Decimal it is 27, and 101 in binary equals 5 in decimal. So 27 divided by 5 gives you 5, and there's a remainder of 2. So when we do it, you do a normal division. The only thing is when you subtract, then you need to remember that you're subtracting with binary numbers. For example, here, 110 minus 101, then you have 2 minus 1 gives you 1. 0 minus 0 gives you 0. 1 minus 1 gives you 0. Right, then you bring down a 1. 101 cannot go into 11. You write down a 0 there. You bring down the other one. 101 can go into 111 once. 111 minus 101 gives you 10. So remainder 10. Right, so you guys are going to do exercise 3. press pause on your screen, work it out within 5 minutes, and then you press play again. So press pause now, work it out, and then thereafter you press play again. As mentioned with multiplication, it's the same up until here. It's only when you add that you need to remember you're adding binary numbers. So 0 plus 0 gives you 0, 0 plus 0 gives you 0, 0 plus 1 gives you 1, 0 plus 1 gives you 1, 0 plus 0 gives you 0, 1 plus 0 gives you 1. Then it's another multiplication sum. You just pay attention here to the addition. 0 plus 0 plus 0 gives you 0. 0 plus 1 plus 0 gives you 1. 0 plus 0 plus 1 gives you 1. 0 plus 1 plus 0 gives you 1. 0 plus 1 plus 1 gives you 10. So write the 0 and the 1 there. 1 plus 1 gives you 10. Write the 0, carry over the 1. 1 plus 1 gives you 10. And you write out the full 10. 3, we have a division. So 10 goes into 10 once. 10 minus 10 gives you 0. 10 goes into 1 0 times. You can't, so you bring down another 0. This one, 10 goes into 10 once. 10 minus 10 gives you 0. Bring down the 1. 10 goes into 1 0 times. Bring down the other one. 10 goes into 11 once. 11 minus 10 gives you remainder 1. Right? So 101,011 equals 43 in decimal, and 10 in binary equals 2 in decimal. So 43 divided by 2 gives you 21, remainder 1. And in binary, it's 10,101, remainder 1. Then number 4, it's exactly the same. You must just remember that when you do the subtraction, that you do it, this is the visual method, that you do it the right way. So firstly, we will work with the 1001. Then you subtract. 1 minus 1 give you 0. Then we go borrow. 2 minus 1 gives you 1. 1 minus 1 gives you 0. Right. 111 cannot go into 1, so it's a 0. We bring down another 1. 111 goes into 1011. Write the 1 there. So I'm just going to quickly show you over here. It's very difficult to explain it when the sum has been done already. So I want you to just look where you wrote and make sure that you understand the 1 minus 1 there, because you borrowed 1. So this one is then actually the 2 you see there. Over here, when you subtract, because we know the division is straightforward, so I'm not going to waste your time with that. So here, 1 minus 1 gives you 0. 1 minus 1 gives you 0. You can't say 0 minus 1, so you go borrow. Then you have 0 there. Then you have 2 minus 1 gives you 1. 0 minus 0 gives you 0. Right. And then over here, 0 can't say 0 minus 1, so you go borrow, then there's 0 there. Borrow, borrow. 2 minus 1 gives you 1. 1 minus 1 gives you 0. 1 minus 1 gives you 0. Right? Bring down. First, you can see 111 cannot go into 11, then you write 0 there. Then you bring down the other one. 111 goes into 111 once. And then you subtract 1 minus 1 is 0, 1 minus 1 is 0, 1 minus 1 is 0. So 0 minus 0 is 0, 0 minus 0 is 0. Right, so the work from page 16 onwards you're not going to write about, so I'm just going to discuss it. So if you feel like you've had enough and you just want to focus on the work which we've done thus far, then you can end here. Otherwise, you can just listen if you want to just enrich yourself. So one drawback to using the binary number system for computer operations is that programmers have to deal with long strings of binary numbers, ones and zeros. So the hexadecimal or base 16 numbering system, which you guys are already familiar with, can be used as a shorthand to display binary content. A single hexadecimal digit represents 4 binary digits. So 1001 binary equals 9 in hexadecimal. In the hexadecimal system, letters are used to represent the numbers 10 to 15. So 10 is A, 11 is B, as you guys know already, 12 is C, 13 is D, 14 is E, and 15 is F. So it only goes up to 15. Addition with hexadecimal numbers, we're quickly going to look at. Right? So we're going to add these two hexadecimal numbers. So first of all, step 1, because we're busy with hexadecimals, you write it, this is like your top heading. Step 1, align numbers below one another. So these ones you're going to align underneath one another. Start adding from the right hand side. 5 plus 7 gives you 12, but remember 12 we write as a C, so that's why you see a C. Then B, which means 11 plus 2 gives you 13. How do we write 13? We write it as a D, that's why you see a D. 1 plus 1 gives you 2, and there you have your answer. Now this one has to do with carrying. So we're going to add these two. Step 1, the headings. Right, so E is a 14 plus the 3 gives you 17. So any answer more than 16 results in carrying over to the next column. So we have one that we write down and one that we carry over. Then 7 plus 1 is 8, plus B is 11. That gives you 19. So we write down a 3 and we carry over the 1. Why do we carry over? Because it only goes up to 16. Answers more than 16 results in carrying over. So 4 plus 1 gives you 5 plus 1 gives you 6. In the decimal number system, we have to carry 1 to the column on the left when the answer is equal to 10 or greater than 10. In hexadecimal system, we carry 1 to the next column if the answer is equal to or greater than 16. Right, so the decimal check. This is the hexadecimal. You convert it to decimal. So 17E hexadecimal equals 382. 4B3, hexadecimal equals 1203 in decimal. 631 hexadecimal equals 1585 in decimal. And 382 decimal plus 1203 decimal equals 1585 decimal, and if we convert that to hexadecimal, it's 631. Right, now we're going to look at subtraction with hexadecimal numbers. So we're going to subtract that. Once again, your heading. We go borrow. Right, we're going to focus here quickly. Rightmost column, we need to subtract A, which equals 10, from 8. We can't, so borrowing from the column 1 placed to the left is necessary. We borrow, we now add 16, because remember we borrowed now 1, so we add 16 to 8, that gives you 24, minus A, which equals 10, gives you 14. 14 we write as a E. Right. Now the middle column. From the original 2, there is 1 left. After borrowing from the left column is necessary. So from C, which means 12, borrow 1. This 1 is added to 16, so we go borrow there. The 1 is 17. 17 minus the 3 gives you 14, which we write as a E. And then you have B minus B, which gives you 0. B minus B equals 0. So the answer is EE. Decimal check. Hexadecimal, we convert to decimal. C28, 16 gives you 3,112. Then B3A, hexadecimal, gives you 2,874. And then EE, hexadecimal, gives you 238 decimal. Right, then exercise 4 is optional. It's only for enrichment, so we're just quickly going to take a look at it. Right, A is 10 plus 1 gives you 11, which we write as a B. Then F is 15 plus 8. Right, and then we carry over the 1. Then you write your 7, carry over the 1, then it's 3 plus 2 gives you 5, plus 1 gives you 6. Number 2, 11 plus 4 gives you 14, which we write as a F. E is 14 plus 2 gives you 16, so we write it as a 0, and we carry over the 1. 7 plus 1 is 8, plus 12 is 20, so we write a 4 and we carry over. 2 plus 1 is 3, plus 1 is 4. And then with the subtraction, 8 minus 7 is 1. Then we go borrow. When we do the second column, then 16 minus 4, 16 minus 2 gives you E, which is 14. And then C minus C will give you 0. And then the last one is also, you have to remember 16 plus 10 first, and then you subtract 14 from the 26. And then you get 12, which is a C, and a 0 and a 7. Right, I'm not going to spend too much time on this because this might confuse you. It's only for enrichment, so that's why I'm not going to go into it any more than I already have. So now we're going to do the homework. We're only going to mark number 1 to 3. Number 4 and 5 is only for enrichment, which you can take a look at in your own time. So I want you to do number 1, 2, 3 for me now, because this is what you will be writing test and an exam on. So we're going to focus mainly on the stuff that you're writing exams and tests on, the compulsory stuff. So you're going to give yourself 15 minutes now. So press pause, work it out, and then you press play again. So press pause now. Right, you're going to add these 3 binary numbers. I'm going to write them quickly for you and add them. One plus 1 gives you 10. 1 plus 1 gives you 10. 1 plus 1 gives you 10. Plus 1 gives you 10. So you have 1, 2, 3, 4, 1, 2, 3, 4, which gives you 10,000 in binary. Then B, add the binary numbers. Remember to add the placeholders. It gives you 11. This one gives you 11. That one gives you 11. That one gives you 10. 11. Right. Then number 2. Subtract the binary numbers. Go borrow is 1. It's 1. 1 minus 0 gives you 1. 1 minus 1 gives you 0. 1 minus 0 gives you 1. 2 minus 1 gives you 1. Then 3.1, almost there. Add all 3 numbers. Then you get that. Straightforward plus. 3.2, subtract the smallest number from the biggest number. I'm going to show you that one quickly. One minus 1 gives you 0. 2 minus 1 gives you 1. 0. 2 minus 1 gives you 1. 0. 1 minus 0 gives you 1. 1 minus 1 gives you. And there you have your answer. Then 3.3 multiply. Up till here it's straightforward. Then it's just adding it up. 0 plus 0 plus 0 gives you 0. 1 plus 0 plus 0 gives you 1. 0 plus 0 plus 1 gives you 1. 0 plus 1 plus 0 gives you 1. 0 plus 0 plus 1 gives you 1. 0 plus 1 plus 0 gives you 1. 0 plus 1 plus 1 gives you 10, and you carry over. 1 plus 1 plus 1 gives you 11. 1 plus 1 gives you 10. You write it out like that. And then 3.4, division is straightforward. You just need to remember that when you subtract, for example here, that you first go and borrow, that you have the 2 there. 1 minus 1 gives you 0. 1 minus 0 gives you 1. 1 minus 1 gives you 0. You can't say 0 minus 1, so you go borrow. So it's 2 minus 1 gives you 1. Right? Those two ones. Then you go subtract again. 1 minus 1 gives you 0. 0 minus 0 gives you 0. 0 minus 1 minus 1 gives you 0. 0 minus 1, you go borrow. So it's 2 minus 1 gives you 1. 1101. Okay, and you goes into 10,000. You add the 1 there. You subtract, so you go borrow. I'm going to show you quickly how to subtract this one. So 2 minus 1 gives you 1. 1 minus 0 gives you 1. 1 minus 1 gives you 0. 1 minus 1 gives you 0. 0 minus 0. So there you have your remainder 11. So it's 111, remainder 11. So the division is straightforward as you usually do. It's just with the subtraction that you have to remember you're subtracting binary values. Right, these ones you can try on your own in your own free time. I just want to rather go back to the basics which we did in today's lesson, the parts that you do write exam on. So firstly, you need to be able to count in binary 1, 10, 11, 100, 101, 110, 111, 1000, 1001, 1010, 1011. Then key results, 0 plus 0 gives you 0, 1 plus 0 gives you 1, 1 plus 1 gives you 10. So you have to remember this. 1 plus 1 plus 1 gives you 11. The decimal is basic to you. Then when you add in binary, you get your answer, you convert it to decimal, and then you check. Do a decimal check. Right. So that will be then the end of our lesson for today. Seeing that we have some errors now with the screen, but that's the end. You must be able to add, subtract, multiply, and divide with binary numbers and be able to convert it to decimal. And that's it. Remember that from page 15, page 16 onwards, you're not writing exam on these. Thank you.